Good morning, students of grade 10. Today in our 6th week we are going to talk about lenses part 4. Today we are going to solve two exercises, one covering the converging lens and the other covering a diverging lens. In the first exercise, a converging lens of focal length 12 cm, an object AB of height 3 cm, which means that AB is equal to 3 cm, is perpendicular to the principal axis or the optical axis of the length and belong to the principal axis such that AO is equal to 6 cm, which means that point A is on the optical axis. In this exercise, the first part is asking to draw the length and the object AB to a suitable scale which we choose, to construct the ray tracing the image A'B', to measure A'B' and OA graphically. Is the image erect or inverted? Check by calculation the position, nature, and the size of A'B'. First of all, we want to draw the lens and the object AB to a suitable scale. Here, we choose the scale. Each box represents 3 cm horizontally and vertically. This is the lens. This is the image focus F'. The distance from O to F' is equal to 12 cm, which is 4 boxes. Each box is 3 cm. This is the object focus F, and this is the object AB, which is 3 cm height, which means 1 box. It's away from the lens by a distance OA equal to 6 cm, which means that it's 2 boxes. In the second part, he asks to construct the ray tracing the image A'B'. To draw the image A'B', first of all, we draw from B a ray parallel to the optical axis. This ray will emerge passing through the image focus F'. The second ray we draw is from B, passing through the optical center O, which will complete undeviated. As we noticed in here, both rays did not intersect, so we elongate both rays from behind so that they will intersect behind the object AB at a single point. This point where the two rays intersect is B', the image of B. From B', we draw a perpendicular line to the optical axis to give us A', the image of A. So this is the image A'B' of the object AB. As we notice from this figure in here, since A'B' and AB are on the same side, this means that this image is virtual image. And since it's virtual, it's an erect image. And since AB is upward and A'B' is also upward, this means that this image is erect and not inverted. Now, measure on the figure A'B' and OA. As we see in our figure in here, A'B' is 2 boxes and each box is 3 cm. This means that A'B' is 2 times 3, which is equal to 6 cm. And OA' is 4 boxes and each box is 3 cm, which means that OA' is 4 times 3, which is equal to 12 cm. This is the size of the image A'B', and this is OA', not OA', which is equal to 12 cm, which represent P'. Is the image erect or inverted? Justify. The image A'B' is erect with respect to AB because both have the same direction. Both are upward. Check by calculation for the position, nature, and the size of the image A'B'. To check it by calculation, we use Descartes' formula. Using first Descartes' formula, 1 over P plus 1 over P' is equal to 1 over F. We know that F is equal to 12 cm and P is equal to 6 cm from the given. So we are going to calculate P'. 1 over P' is equal to 1 over F minus 1 over P. By substituting, we get that 1 over P' is equal to minus 1 over 12. So P' is equal to minus 12 cm. So P' is true for the value calculated for OA', which is equal to 12 cm, so it's correct. The position is correct. Since P' is negative, as we said before, then this gives us that the image is virtual. If P' is positive, then the image is real, but since P' is negative, so this gives that the image is virtual. Now, to find the size of the image A'B', we use the magnification ratio, which is M equal to A'B' divided by AB, and it's same equal to minus P' over P. P' is calculated, P is given, and AB is given also. So to find A'B', it's equal to 3 times minus 12 divided by 6, and we have a minus in here, so minus and minus will give us plus, which gives that A'B' is equal to 6 cm. so our calculations are verified. In the second exercise, an object AB of 10 cm height is placed at 15 cm from a diverging lens of focal length -5. As we know that for any diverging lens, the focal length is negative. So the focal length is -5. The object AB have a size 10 cm and its position is 15 cm away from a diverging lens. Determine the position, the nature, and the magnification of the image A' B' of AB using Descartes' formula. So, to determine the position, the nature, and the magnification of the image A' B' of AB, we use Descartes' formula. 1 over P plus 1 over P' is equal to 1 over F. Using the given, we know that P is equal to 15 and the focal length is equal to -5 cm. So by substituting 1 over P' is equal to 1 over F minus 1 over P, we substitute F by -5 and P by 15, we get 1 over P' is equal -4 over 15, which gives that P' is equal -15 over 4, so P' is equal to -3.75. As we said, if P' is negative, this shows that A' B' is a virtual image and not real image. Now, to find the magnification is equal to -P' over P, which is -3.75 P', which is calculated in here, divided by P, which is given, so we get that the magnification is 0.25. Now, he's asking, is the image A' B' erect or inverted? The image A' B' is erect since A' B' is a virtual image, and whenever it's a virtual image, so it's erect. Whenever it's a real image, it's inverted. Can the image be collected on a screen? No, the image A' B' cannot be collected on a screen because it's virtual image. As we know, any virtual image cannot be collected on a screen, while any real image can be collected on a screen. Calculate the size of the image A' B'. To calculate the size of the image A' B', we can use the magnification ratio. This magnification gives us that M is equal to A' B' divided by AB. M is calculated in the previous parts, 0.25. A' B' we want to calculate it, and AB is equal to 10. So A' B' is equal to 0.25 times 10. This is 0.25 and not 0.22. So A' B' is equal to 2.5 centimeter. Now he asked to represent on the figure to a scale 1 over 5. When I give you a scale 1 over 5, this means that any value you have in the given, you must divide it by 5 to represent it on the graph paper. He wants us to represent the object and the image. Given B is on the optical axis of the lens. So this is our diverging lens. The scale is that each box represents 5 cm, which means that the focal length, which is 5 cm, is represented by one box. The object focus away by one box, and this is the image focus F'. It's also away by one box, which represents 5 cm. The object AB is at distance 15 cm from the diverging lens, which means that it's away by 3 boxes. The image A' B', its position is 3.75, which means it's less than 5 cm, which is from O till B', it's 3.75. So this is the representation of our length we have in here. Now he asked to draw the path of the rays issued from A. First of all, we draw from A ray parallel to the optical axis. It will emerge seeming to come out from F', as shown in here. This ray will emerge as if it's coming out from F'. The second ray is passing through the optical center O, which will complete without deviation. Both rays will intersect at a single point. This point is the A', the image of A. From A', we draw as usual the perpendicular to the optical axis, which represent B', the image of B.